There are substances out there that do not dissolve in water. I'm sure you can think of quite a few. Oil, gasoline, like olive oil, cooking oil. What else doesn't dissolve? I mean, there's a bunch of different things that does not mix with water. And the word that we use for things that do not mix with water is hydrophobic. So hydro again, meaning water, like hydroelectric or hydroplaning, and then phobic, meaning like a phobia, like scared of. So literally this means does not like or is scared of water. So substances that do not dissolve in water, for example, oil is a great example. Why do they not dissolve in water? Well, we can explain this now down to a molecular level. What's happening in the molecules? If we could zoom in on these molecules and zoom in on these molecules, this is what we'd see. Here's the water and here's the oil. All right, so water molecules we are pretty familiar with. They look like this and they have partial charges and they attract each other, which is what all these dotted lines are showing, all the hydrogen bonds attracting these water molecules. Here is a molecule of, now this is actually looks more like gasoline, but it could be oil. If we look at this molecule here, the question is, does this molecule have charges or partial charges? Because that's how you're going to know if water is going to be able to mix with it. Water will mix with things that have charges. So if you see like a plus or a minus, you'll know water will mix with that. Or partial charges. Now, how do you know if something has partial charges? Well, if we think back to what we learned last week, you get partial charges when you have a very electronegative element. We had our list, which was F or O or N or Cl or S. One of these atoms, if one of these atoms is joined with a bond to hydrogen, then you have unequal sharing of electrons, and all the electrons get sucked towards the electronegative bully, and this makes this atom a little bit negative and makes the hydrogen a little bit positive. So if you want to find out if something has partial charges, you need to look for the F, the O, the N, the Cl, or the S, that list of electronegative elements, and see if one of those is attached to H somewhere in the molecule. Now, if we look over here, I don't see any Fs or Os or Ns or Cls or Ss. So there is no electronegative, there's nothing electronegative, highly electronegative in this whole molecule. It's just carbon, which is not a bully. Carbon likes to share its electrons fairly. And hydrogen, which is also not a bully. It likes to share its electrons nicely. So this is a nicely sharing molecule where all these covalent bonds are evenly shared pairs of electrons. And so there's no imbalance, there's no slightly negative side, there's no slightly positive side. There is no charge going on in this molecule. So these molecules, we would call them non-polar. Polar is when you have opposite sides, like a positive and a negative side, or a slightly positive and a slightly negative side. For example, down here, this water, this is polar. There's a negative side and a positive side. So this is a polar molecule. This is a non-polar molecule. And there is nothing that attracts this molecule to this molecule. There's no attraction here. So if there's no attraction, they're not going to mix together. And in fact, these water molecules down here would much more likely want to be attracted to each other and they don't want anything to do with all this stuff up here. And you see that if you take water and oil and try and shake it up, it will kind of mingle together, but eventually they will completely separate out. The water molecules will go back to themselves and attract each other in a big watery lump at the bottom. And then the oil will be pushed out. The water will say, we want to attract each other. We don't want any part of you. We're not attracted to you. And these oil molecules will be sort of expelled or removed out of the water because there's no attraction there. So now you have a little thing to look for to decide if something is going to be hydrophilic, like water, or hydrophobic, not like water. If you're shown a molecule, a structural formula of a molecule that you've never seen before, you don't know what it is, and someone asks you, is this molecule hydrophilic or is it hydrophobic? Like, how do I know? I don't even know what it's supposed to be. You don't have to do that now. You can say, okay, well, let's look at it. Does this molecule have partial charges or not? I'm going to know if it's going to have partial charges by looking for O or F or N or Cl or S. If it has one of those atoms in it attached to a hydrogen, then it's going to have partial charges. And if it has partial charges, water is going to be attracted to it, which means it's going to be a hydrophilic substance. So I might not know what the name of the molecule is. I might never have seen it before, this mystery molecule. But I could predict that it's going to dissolve in water because it has partial charges. On the other hand, if I can't find any partial charges, if I don't see no F or O or N or Cl or S, and if it looks more like something like this, then I can say, okay, that probably is not going to, there's nothing for water to attract to here, so this is probably going to be a hydrophobic substance.